Last time I presented to you our initial list of theorems to obtain the limit of functions. And suppose we have these two functions, f and g, and their limits exists as x approaches a and c is a constant. We showed that the following rules apply. You know what? Looking back at what I did, I felt that maybe I just did a lot of explaining and maybe it was not necessary for me to do it. But I chose to do it that way because that is how you build knowledge or the body of knowledge, which is math. You begin from the foundation. You begin from the details and then you put those details together to produce something that is more significant and more useful. So as you can recall it, the way I explained these theorems is I always kept on returning to Theorem 1.1, which tells us how to find the limit of a function and how to establish that the limit of a function exists. It is through the one-sided limits. But now that I have presented to you this list of theorems or this list of rules, I ended my last video by stating that if your function is a polynomial function, the limit of that function as x approaches a is just f of a. So you just have to evaluate the function when x is equal to a. Find the limit of or the limits of polynomial functions. So let us do this. It's equal to 16. Find the limit of x cubed minus 3x plus 2 as x approaches negative 2. So it is equal to 0. You know, in exercises like this, and if your teachers want you to submit your solution, what your teachers want to see is an orderly and neat solution. And how do you produce an orderly solution? This is how you do it. You begin from the left, you go to the right, and then from the top, you go to the bottom. Your conclusion is at the bottom. That is how you produce an orderly and neat solution. How about this? The limit of 2 times x to the fourth minus 3 times x squared minus x plus 1/2 as x approaches negative 1/2. Okay, so pay attention to this. This is 1 over 2 to the fourth. Okay, but this one is 2. So 2 divided by 2 to the fourth will give you 1 over 2 cubed, and 2 cubed is 8. And this one is negative 1/2 raised to 2, so that's just 1/4. So negative 3 times 1/4 is this one. This one is, look at this, minus negative 1/2. So that is just 1/2. And then plus 1/2, so that is just equal to 1. Okay, so let us simplify this. So the limit of this function as x approaches negative 1/2 is equal to 3 over 8. So we shall add more to the list of theorems that we have about functions. If the limit of f of x and g of x exists as x approaches a, the following rules apply. The limit of f of x times g of x as x approaches a is just equal to the product of their limits. The limit of f of x divided by g of x as x approaches a is equal to f of a divided by g of a for as long as g of a is not equal to 0. So basically, when your function is a rational function, so we are limiting our functions so that f and g are polynomial functions. And so when you have something like this now is what you call a rational function. So it's the same with rational function. If we want to evaluate the limit of a rational function, we just evaluate it. We just evaluate it at a. But we have this restriction. G of a must not be equal to 0. Okay, so let us find the limits of these functions. So these are polynomial functions, and we know that their limits exist for any real number a. So all we have to do is just get the product of their limits. So this one, as x approaches -1, is just equal to -2 times, this one is +1, -2 plus 3 is 1, and then times -1. So it's -2 times 1 times -1, and that is just equal to 2. Okay, so pay attention to the law of signs. Negative times negative is positive. So let us organize our solution. So let, f of x, our numerator, is equal to 2x squared minus 5x minus 4. So what is f of 2? So this one is equal to 8. This is equal to -6. Now let us go to the denominator. Let g of x be equal to x cubed minus 1. Let us evaluate g of 2. So this one is 2 cubed minus 1, and that is just equal to 8 minus 1, which is 7. Okay, so the limit of f of x divided by g of x as x approaches 2 is equal to -6 over 7. Find the limit of x squared minus 6x plus 8 divided by x plus 4 as x approaches 4. So be careful with this. 0 divided by 4 is 0. If this were 4 divided by 0, that is undefined. But 0 divided by 4 is 0.